In section 2.5, we're going to talk about using linear models. So here we're going to make scatter plots, look at trends in data, and ultimately figure out how to make a trend line. I think this section is really cool because unlike some of the other sections that we've gone over, this information is really, I think, generally kind of interesting, a little bit more useful and applicable to the real world than other sections that we might look at. So to start off for today, let's review what a scatter plot is. A scatter plot is a graph that relates two sets of data by plotting that data as ordered pairs. From there, once we plot everything, we can look to see if there's a trend in that data. You can use a scatter plot to determine the strength of a relationship or a correlation between data sets. We call those trends correlations, and we quantify them using a correlation coefficient. So here you kind of see the range of correlations that you might have, ranging from a strong negative to a strong positive. The numbers that we use for the correlation coefficient range from -1 to +1. -1 would be a perfect straight line going downwards. A perfect positive relationship would be a perfect straight line going upwards. The closer you move towards no correlation, the closer you move towards 0. So like a weak positive correlation would be something like +0.6. Strong positive would be something like +0.9. Same thing kind of going the other way. So here, looking at our first example problem, we're going to look at two different variables, plot them out on a scatter plot, and see if we can determine any sort of trend or correlation between the data. Here we see the average monthly temperatures and electric costs for one Texas home in 2008. So when we plot these, we're going to think of the temperature and the electric bill, those numbers, as a coordinate. So to plot 61, 150, I would go over to around where 61 is, go over to where 150 is, and plot it like so. When you're doing problems like these, you don't want to worry about being specific. So I wouldn't be too worried about thinking exactly where 61 and where 150 is on this scatter plot. As long as you plot all of your dots generally where you're supposed to be, we're looking for an overall trend, so they don't have to be in the exact spot for us to pick up on that trend. So after I plot everything, it would look a little something like this. So from here, from all of the dots, I can see that I kind of have a positive upward trend, something a little bit along the lines like this. From here, I could say that I have a strong positive correlation. How we would word that is by saying that as the temperature rises, so is your electric bill. So as temperature goes up, electric bill goes up. In other words, a strong positive correlation. So that line that I just drew is something called a trend line. A trend line is a line that approximates the relationship between variables. So something like this. What we're going to do from here is we're going to figure out how to make our own trend line by hand. Our calculators can also use something called the line of best fit, which would be the most accurate trend line that most evenly goes through all the data points. In this equation, or in this question, we're looking at Florida's average home prices, since 1940, and we're going to make a trend line and then use that equation for the trend line to make predictions about the future. So here we see starting in 1940, the home price is around $23,000, and we see it every 10 years going up to $2,000. How we're going to plot this is instead of saying 1940 and the X graph, we're going to look at 1940 as our starting point, or at 0. So our first plot would be at 0, around where 23,000 would be. And then we're going to look at everything from there as years since 1940. So 1950 is 10 years past 1940, so I'll be at 10, 40, 1,000. If I keep plotting out these points, I'm going to have something that looks like this. So from here, when I want to make a trend line, I'm going to look at two dots that I can connect that seems like it would be the most accurate line going through all the points. So here I'm going to pick this coordinate, and I'm going to pick this coordinate. And then making my line. I agree, that kind of holds up. On any question that you'd see like on a quiz or test or anything, those points are going to be given to you, so you don't have to worry about trying to pick out which ones would be the best ones. From here, I am technically working with the coordinate 10, 4100, then 2000 is 60 years past 1940, so I'll have 60, 105, 500. So here, kind of tying in what we did in the last section, when we have 2 points, that's all that we need to make a line in point-slope form. So, as a reminder, point-slope form is y minus y1 equals your slope, x minus x1. So all that we really have to do here is find the slope, pick one of these 2 coordinates, make our line from there. So to find our slope, I'm going to subtract my x values, or my y values, and take it over subtracting my x values. I'll get the slope to be 1308. From here, I'm going to plug it in. I'm going to pick this coordinate. Again, doesn't matter which one you pick. Minus my x coordinate. From here, working in section 2.5 and making trend lines, I'm going to want to have it in slope-intercept form because from there we can interpret it a little bit better to see what this equation is really telling us. So again, I can do that in 2 steps. Last step, I need to get y by itself, so I'm going to add this over, and I'm left with the equation y equals 1308x plus 27,020. So basically our trend line is telling us that starting at a home price of around 27,000, judging by that data, our average home price is going to increase by $1,308 every year. Now again, as we saw, 1940, the home price started at 23,000, so this equation isn't exact, but again, it's just kind of creating like a trend for us. So this line, I guess, would be the most accurate overall. From here, our last step is we want to find, or using this trend line, what can we predict the average home price to be in 2020? So all we have to do is find out how many years past 1940 is 2020, plug that in for x, and we'll have our answer. I can see that 2020 is 80 years past 1940, so what I'm going to do is I'm going to plug 80 in for x, add that all together, and I'm going to get my home prediction, or my home price prediction, to be $131,660. So that is how you would do this by hand. Your calculator or your TI Inspires or TI-83, whatever you have, any graphing calculator can solve this if you just plug in your values as lists. We'll learn how to do that in class, but here this video is mainly just going to focus on how could I do this by hand if I wanted to.